So the first question is, what is the point called where the perpendicular bisectors of the sides of a triangle intersect? So we talked about 4 different types of points here, and the 4 points are nice and organized on page 339 if you want to look in your textbook, but you have the circumcenter, you have the incenter, you have the centroid, and you have the orthocenter. So they've described each one, and the one that has the perpendicular bisectors with it would have to be the circumcenter. So number 1, the answer would be, circumcenter. Okay, so that is really just about knowing what the word is, okay? Something that might trigger it would be look for if it's describing about perpendicular bisectors, because that will tell you that that's also the circumcenter. So number 2. Number 2, it says in triangle ABC, point H is the centroid. It says AH is 8. Find HY. Now this one, the way that it was drawn was a little bit hard to tell whether HA was the 2/3 or HY. I'm going to say HA was the 2/3 part, and HY would be the 1/3. So if you're going to split it up into 2/3 and 1/3 of a certain total, what would be HY? Well, first off, you could come up with the total. If 8 is 2/3 of the total, what's the total? Think about that. 12, right? Okay, so 12 is the total, 8 is AH, so what would have to be HY? 4, yeah, okay, so 12 would be the total, and then 2/3 is 8, so 1/3 is 4, and you're doing 1/3 of 12 and 2/3 of 12 is what that is. So 4 would be your answer. And that's always when you're doing centroids, you'll have the 2/3 is the longer side and the 1/3 of the total is the smaller side. And then number 3, a lot of us needed to know what this one is. It says, what is the name of the point that is 2/3 of the way from each vertex of a triangle to the midpoint of the opposite side? Again, this is on page 339, where it has all 4 of them summarized, but the only one that talks about 2/3, and actually the one we just did, would be centroid. Okay, so number 3 would be centroid. Now, number 4 and 5, it asks you to find the value of y and find the value of x. So we have a quadrilateral GHIJ. It says HJ is the perpendicular bisector of GI, and GI is the perpendicular bisector of HJ. Okay, and then it gives you 3 out of the 4 sides of this quadrilateral. So if we know that HJ and GI, HJ and GI are both perpendicular bisectors, okay, what will that tell us about the sides? Like, let's compare if you're looking at HI and JI. Would those be the same? Because it's split up into 2 parts there by the perpendicular bisector. So those would be the same, but that doesn't help us because it says one is X and one is Y, so we can't put them equal to each other just like that. But then if you keep going, wouldn't Y plus 2 be equal to 2X plus 2 in the same idea there, because you have a perpendicular bisector? Okay, again, we can't put then Y plus 2 equal to 2X plus 2, but we can use the transitive property just in our heads, and we could do Y plus 2 then would have to be equal to 3Y minus 4, because they're both equal to 2X plus 2. So if you put them equal to each other, the Y's, Y plus 2 and 3Y minus 4, that you can solve for Y. And then you can use what you got for y to, again, solve for x. So we're solving for y here. We got to combine like terms. You get 2y minus 4. So y would be 3. If you divide by 2. So y would be 3. Now, if we use that, we can just plug in either the 3 for the y plus 2 and put it equal to 2x plus 2, or we could put in the 3 for the 3y minus 4 and also put it equal to 2x plus 2, but we just need to substitute it in. So let's make it easy. We just put it in for y plus 2, so that's 3 plus 2. So to solve for x, we would have the y plus 2, gh, equal to hi. So 5 equals 2x plus 2. And we'd solve for x now. So, and I made these numbers up, so that's probably why. Oh no, 2. That's probably why it's a fraction. But you get x is 1.5, or 3 over 2. Okay, so y would be 3, and x would be 3 over 2. I know a lot of you had questions on that. Does that make sense how we kind of went around? Okay, you want to use what you have and just kind of go around and try to eliminate different ways of doing the problem, and that way you can solve it the proper way. What? X is here. Okay, so the next one is kind of a small figure, but it says determine in the figure which angle has the greatest measure. Well, what do you think?
Angle 1.
Yeah, I would say angle 1, right? Because angle 1 is adding up 3 and 4 together, and then angle 1 is the obtuse angle when you're putting it next to 2, so it has to be the greatest angle, so angle 1. Yep. All right, and then the next two are finding the shortest segment and the longest segment, and they give you the different angle measures here. So you have finding the shortest segment in triangle ABD. Well, ABD, you have 56, 63, and 61 are your 3 angles. How would we know the shortest segment? Yes.
It would be BD, because 56, if you want, draw a line across.
BD, because BD would be across from the smallest angle, which was 56. So BD would have to be the shortest segment. Then it says find the longest segment in triangle BCD. What would that be? DC, because that's across from 75, which is the largest angle in triangle BCD. So CD would be number 8. That's the longest. And then numbers 9 and 10 are the opposite kind of thinking. This time you're using the sides to figure out the smallest and largest angles. So this one is find the angle with the smallest measure for triangle QPR. What would that be? Angle P, because that's across from 6, which is the smallest side on that triangle. So angle P would have to be the answer for number 9. And then number 10, find the angle with the greatest measure in triangle PRS. So that's angle with the greatest measure would be what, Amy?
R.
Angle R, yep. Because that's across from the 9, which is the greatest side. So any questions on any of this? This is basically like your preview of your quiz. So if we feel comfortable, we should do pretty well.